Alright, so you will never guess what platform we are going to have a video today on, because it's LeetCode, and you may get suspicious, like it's not a contest day today, so why would I make a video on LeetCode? Well, I decided that it's better to upsolve problems, not to upsolve. So today I want to upsolve weekly contest something. I believe it's 239. And I also should be something like this. Okay. So we can, as you know, participate in a virtual contest, and that's exactly what we're going to do. I believe I haven't seen the problems yet, so it will be more or less fair. Well, let's go. Yeah, I want to start go to contest. I believe here what you want to do is open all problems immediately. And then start solving them. So first problem, minimum distance to the target element. We're given an array nums and two integers target and start. We want to find an index I such that nums I equals target and abs I start is minimized. Alright, we want to return the absolute value. Okay, and it's guaranteed the target exists in nums. Alright, the naive approach would be just for index num, just loop over nums, right? Enumerate nums. And we also want something like minimum absolute difference, initialize it to, I don't know, len nums. Seems reasonable. If num is equal to target, and we probably want minimum absolute difference to get minimum of its current value, and then currently absolute value of index minus start, and we want to return minimum absolute difference. I believe if it's guaranteed that it exists, then we can just submit it. How do you... Oh, there is no, okay. And it's got accepted, well, that's as expected. Problem B is splitting a string into descending consecutive values. We're given a string that consists of only digits. We want to check if we can split S into two or more non-empty substrings such as the numeric values of the substrings are in descending order and the difference between numeric values of every two adjacent substrings is equal to 1. Well, that's going to be a bit uncomfortable, and apparently we also can have leading zeros. There, but the string is very short. What do I want to write here? Let me think. And we can do things like that. Okay. Okay. So apparently we would like to make a recursive call, and we would like that recursive call to return what is the starting value or starting values if there are several values. Okay. Start at position I. We can cache it, although I believe the way you want to do it is from cache is in functools. I believe we have some starting index. We want to return the set of numbers that can be first number in such a partition. So and we want to return that start of 0 is not empty. We can just cast it like this, I believe. And how do you implement this string? Well, you can always have, like, if you convert the entire string. Oh, okay. This condition will be slightly different. So you can always start with converting the entire string from index and onwards. Right? Potentially you want to do it like this instead. Then for every partition index, you say like, okay, what if this is going to be our return set. So what is the first part? So suppose the first part is first I characters, right? What do we want to do next? Well, we want to call start recursively from that position onwards. And we want at least one character here. So the rest will be like first number that can be here. Right? And if first minus 1 is equal to rest I, let's say, because rest is a set, so we have to loop over it. Actually, that's not a good way to do it. If first minus 1 is in rest, right? We want to add a value of first here. This can be clearly simplified. Right, suppose now I want to return the set R. And I want to say that it is not equal to int of s. So like we have something more than the original string, right? From functools. No, I wanted to just import functools. Yeah. False, true, false, true. Does it match? False, true, false, true. Do we have like strange cases? No, I believe we don't, because if the numeric value of string equals the numeric value of its first part, then they are the same. Although I am a bit worried about cases like 0, 0, 0. It says that we don't in either case, and I believe this is a correct one. They also provide several samples here. And I'm doing this because like on binarysearch.com you don't have a penalty for wrong submissions, which I believe encourages people a lot to try, just to try. And here we do have a penalty, so I don't want to get a penalty unnecessarily. But here I believe, like, if we get a penalty, no, we don't get a penalty, but it would have been well deserved if we got one. Because like we checked several cases, came up with several stupid cases of our own, and we also used these cases. Sometimes they give you more cases than examples. Okay, so problem, nothing interesting so far. Problem C is minimum adjacent swaps to reach the case smallest number. When given a string number representing a large integer and an integer k, we call some integer wonderful if it is a permutation of digits in nums and is greater in values in num. There can be many wonderful integers, however we only care about the smallest valued ones. Okay? Oh, that sounds really bad. Although, however, okay. I believe it's easier to do it in C++ because we have std next permutation. I don't really know, like, if it was supposed to be difficult, I believe that we can just do next permutation several times. On num, probably. Wait, what do we want actually? On the minimum number of adjacent digit swaps that needs to be applied to num to reach case smallest wonderful integer. Okay. Also, now we found our integer, right? Okay. I believe you can just copy like that. It will still work. Now we want to return like distance of these two guys. How to return a distance? That's a good question. It's a very good question. Like, of course we can do it naively, I believe, in length squared. I mean, we're doing that much work already here, so it's not much of a problem if we add the same. So here we'll have two indices for num and copy. And my idea is, actually we can say something like that. Let's say n gets a length of num. Then I will loop our all positions in num. And I believe it's a terrible way to compute the distance, but whatever. So we are going to loop, and if we find j is smaller than n and copy j is not equal to num I. Yeah, while this happens, we can, well, actually we don't need first condition because we are guaranteed that they are permutations. We will increment j. So when we exit the loop, copy at j is equal to num at j, and while j is greater than I, can do swap copy j minus 1 minus minus j and plus plus distance. And just like that, in terrible quadratic time, we will get our distance. Answers seem to be 2, 4, and 1, which appear to be illegal. We also have one, oh, okay, this is the same test case. I'm a bit worried, like, maybe next permutation does something strange, but no, like here we got just what we expected. We can also, you know what, we can also print num just to make sure that the numbers that we are getting are the same. 1, 3, 2, 5, 4, and this number, they look the same, but we should comment it not to exit output file limits. Okay, now we got accepted. I don't know what was the idea of that problem. Well, potentially they wanted us to implement next permutation ourselves. And by the way, if we did, we could also compute the distance at the same time as we compute the next permutation, because obviously we employ a swap-based algorithm for the next permutation. So yeah, we could do it in place, but apparently it was not necessary. Okay, so the last problem, problem D. In case you're wondering why I name problems with letters, like most of you should not be wondering, but just in case, it's because of Codeforces and many other competitive programming websites that do name their problems with letters instead of boring IDs. So we are given a minimum interval to include each query. So we're given a 2D integer array intervals, which is actually an array of pairs, but LeetCode apparently will never acknowledge the existence of std pair. So it describes the ice interval starting at left eye and ending at right eye, inclusive, of course. Nobody likes half intervals, half open intervals. I don't know why, they're very convenient, but also they don't exist for LeetCode apparently. So the size of an interval is, no, I'm just joking, you know, don't take everything that I say seriously. So the size of an interval is defined as number of integers it contains, or more formally right minus left plus 1. This plus 1 is exactly why people use half open intervals. So we are also given an integer array queries to answer j's query in the size of smallest. The answer to the j's query is the size of the smallest interval I, such that left I is less than or equal to queries j, and greater than less than equal to right I. If no such interval exists, the answer is -1. Okay, so we want to find the smallest segment that contains our query, and apparently we have a lot of integers and a lot of queries, and therefore we cannot just have two nested for loops. But it doesn't seem much of a problem. It does not seem to be very problematic for us. I believe we can just create a bunch of events. So, events for left, right, for index left, right. So we want to loop our enumerated intervals with the idea that we will append tuples to events which behave like left, then I believe index, and then well, it doesn't, no, it does matter. Let's say what events do we want to process first? We want to process open events. Close events, so just a small comment here. 0 means left, 1 means query, and 2 means right. And why we want to do that will become transparent very soon, because we want to sort the events, of course. And we want to process left events first, then query, then right events. Because we are absolutely fine if query is equal to right j or right I or whatever. So here we want position of the query 1 and then index. For position type, although we cannot just name type, so I will name it type like that. And then index in sorted events. We don't need to put several things into our, like, first of all, we want to create answers, which will just create an empty list so far. We will want to return them with the idea being if type is equal to 0, and we want to do something. Well, if type is equal to 1, we want to do something, and else type is equal to 2, and we also want to do something, but here we will append something to answers. Or rather not append, but place it at the index, and it's actually, yeah, we should initialize it immediately. Len what queries. And here answers at index of a query should get something. Alright, I don't know what, but it will get something soon. Now we want to have we want to maintain all open intervals. Alright, we are going to, well, that's kind of not nice way to do it, but I believe, I actually don't know if we can use sorted dict, because that would be a perfect fit here. What we're going to do instead is use priority queue and set of closed will be a set of closed intervals. Then open will be a priority queue. Opened, whatever. So whenever we encounter left, we say opened. We want to heap push something there. Heap is a minimum heap, I believe, by default. If it's not, we can easily fix it. So what do we want to insert? Intervals at index 1, which is the right endpoint of that interval, minus that plus that. That's not really good, but we can improve it like so. Length get this, and here length we append right minus left plus 1. And therefore here we can use just this. But we also want to push an index on top of it, because we'll need this index to distinguish whether the interval is closed or not. Here we will just add that index to closed intervals. Here, while we have opened intervals, we cannot do that. We will do that. Gets what? Gets a heap pop of that. A priority queue. And if interval index not in closed, and this gets this, and we actually want to heap push it back, because one interval may be the answer for multiple guys. And we also want to break out of that while loop. Otherwise, opened will the open intervals will end, and we will be able to just say that we have -1 here at the beginning, so we just did not put anything here, so that's fine. Right, but here we have some problem which says that length at index is not subscriptable. I don't exactly understand what happens here. Because you see, index is this. It says that int object is not subscriptable. I suppose it assumes length. Oh, because we redefined length here, of course. It's always simple. Uh, 3314, 3314 to -146 to -146. I don't really know. How about we just submit it? Okay. Well, that was not a difficult contest. Let's see how we did. So we solved everything in like 28 minutes, which is terribly slow. No, it's not. Wait, really? I would have been number 5 if I just did everything right. Okay. Okay. Well, that's interesting. You know, it gives me some motivation to participate in the next contest. Not virtual, I mean. That is definitely interesting. if you think about it, like Laurie, we are pretty much head-to-head on binarysearch.com, I believe, although I missed several contests, and at the moment I have a little lower rating. But the fact that we like boss could have, like, I mean, I could have been pretty much in the same place. It's interesting. Of course, we don't have, well, actually, S-Max is quite a tough opponent, of course. But other than that, I don't really see that much of a competition here. Alright. Well, maybe it's because I'm doing this contest in like 4 p.m. in my local time zone, and usually LeetCode weekly contest is like at 5 a.m. in my time zone, so that's maybe why I was getting worse ranks previously. But if this is the current standings of things, then I'm definitely into participating in the next contest. Because, you know, because why not, right? Actually, what is Larry? What's his rating here? Just interested. Oh, okay, so it's like significantly higher than my current rating, which makes sense for me to participate in the further contest, because I believe that, well, I definitely have much less experience, but it will not be such a problem. Okay, so well, I guess it is always interesting to just solve some problems to sort of keep yourself in shape. And in case you missed the weekly contest 239, then I definitely advise you to participate in it. It's not particularly difficult. Particularly difficult. No, I just, I don't know, sometimes I'm trying to say a lot of words, whereas I should just wait for everything to calm down. Okay, so who knows, maybe next time we'll have a live screen test of such a contest. Because that's interesting. That is. I mean, it's an easy contest, but still, I don't see a lot of people finishing already. And like, actually some people had a lot of bugs where it is not necessary. I mean, I also had some bugs in my first LeetCode contest, so that's not a question. And we definitely spent much more time than we should have here. But here, switching to C++ was a major advantage. I believe it is not prohibited next permutation in any way, so that's it. Yeah, so thanks for watching, everybody. I hope it was somewhat helpful. Well, I guess, like, if you don't have anything to do on the work week in the evening, then definitely can upsolve some contests. And if you don't want to throw yourself into a bunch of hard problems from Codeforces or AdCoder, then you can definitely upsolve LeetCode or binarysearch.com weekly and bi-weekly contests. Maybe it's more useful than doing nothing. I definitely believe so. So yeah, everybody, thanks for watching and see you next time. Bye bye.